So what I'd like to do is introduce Andy Terrell. He was the president of NumFocus, the nonprofit that helps organize this entire conference and also helps run and handle sponsorship for all the PyData projects out there. So please give a warm welcome to Andy.
Thank you, Brett. I just want everyone, so these conferences don't happen without a lot of hard work. And so if anyone's on a logistic committee or on a NumFocus staff, I want you to stand up right now and recognize these folks. So Brett and Steve and James and Leah, Lisa. So without these folks doing a lot of hard work, we wouldn't be here today, even though we have a really great room provided by our sponsors and everything like that. It takes a lot of hard work. So I wanted to just start off with a quick 10 minutes of who is, what are we, where we come from, what is PyData, what is NumPy, or NumFocus and whatnot. And so first off, PyData is a community. There might be, I don't know, 100, 200 people in the room today, maybe more, I forget the numbers. But we're actually a worldwide community, and if you go to our websites, you'll see a lot more details on our annual reports and our meetup groups. There's 33,000 people who come under the PyData umbrella today, all the way from Oslo down to lower Argentina. It's so across the globe, lots of people coming together, learning about the ecosystem, learning about our codes, and really participating. In the last year, we had 9 conferences in 7 countries with 300 speakers. We've got 13,000 Twitter followers, and so on and so forth. So we're just growing and growing and growing. I actually had to update this slide this morning because just 6 months ago, the numbers were exponentially smaller. So the community is growing. It's very vibrant. We encourage you to participate in every chance you can. But what starts before you have a PyData conference is you had projects. And many of these projects were committers to open source repositories, scientists, citizen scientists, also people in companies, and all sorts of places that didn't really have a home in order to work on their code, to market their code, to help them with legal issues, and so forth. So NumFocus was an organization started to help that. And PyData is one of our premier conferences talking about these projects. But at the end of the day, the reason we're here is to support these projects so we can continue doing really great work. And it's sort of things that you really don't expect when you start talking about all right, I have PyTables, which is an interface to some memory thing on disk in some special way. But at the same time, or Pandas, which has a really terrible interface, but for some reason all these wonderful people who do crazy amounts of math like it. I don't know. I have yet to be to a PyData conference where somebody didn't tell me how terrible Pandas was, and so, but we still use it. Just some new projects that are very excited about, like Interact, which is trying to lower the computer literacy that you must need to interact with all these tools. How crazy is it that you have to learn how to run a web server in order to fire up the favorite interface to view just some writing in our ecosystem? So the Jupyter Notebook and Interact kind of comes and helps with some of those for folks who are like, what's a web server? And so on. So there's a lot of really great work from these projects, but they don't get started without an organization that helps feed them, and that's what NumFocus is here to do. And we've seen all sorts of really wonderful applications, everything from predicting when oceans rise to when hurricanes are going to hit, that's Hurricane Sandy, and predicted accurately with PyData ecosystem exactly where the tide was going to raise, and all those builders who didn't listen to us. And even a gentleman in our audience, Andreas, took us to the Filet Comet. So we're even extraterrestrial, and even something that Katrina and I had worked on in the past is helping find missing children on the internet, and so on. So we've gone to really wonderful things that are done because we get in this room, talk about really bad interfaces and mathematics and so on, and I'm really proud of that. Oh, and then a crazy startup with some fashion stuff. We won't talk about that. But one thing I just want everyone to consider is what happens when this code doesn't get maintained. What happens when we don't come together, we don't have community, we don't have people supporting us. And just like an old house, we break down, projects go away, I was just talking with some people about the old fight between numeric versus num array, and things like this. And we need to constantly rebuild. And to constantly rebuild, we need organization to do that. And num focus has kind of come on as a organization to help do that. And I put up, if you want to learn more about us, go to our website. But here we have our income versus our expenses. And you can see on the right-hand side here, or left-hand side, all our income mostly from grants and workshops, which wouldn't happen without organizations like this, the community. And then that big I guess greenish thing there is us. It's workshops like this where sponsors come and help us run these conferences and raise money to bring back to these projects, and then you come to the right, and that big dark green is all the money we give back to professionals and contractors to help these projects. And so our numbers here are directly supporting these projects. So everything we do, by coming together, by talking it, by exchanging ideas, comes back to the entire ecosystem. But we couldn't do it without these fine folks. All of our sponsors, I think that the PyData Seattle is blessed with a number of really great sponsors who have come. Not every conference we put on, so, PyData Madrid, it doesn't have nearly as many tech conferences. So by being able to support organizations here, we're able to support the worldwide community and so on. And so thanks so much to these sponsors. If we get a round of applause to all these sponsors, please. And especially Microsoft, who gave us the venue. There's one single thing that makes or breaks a PyData as far as giving money back to the community, and that's whether we can get a venue sponsor or not. And by far, the rooms and the coffee cost more than you can ever believe. It's just like, what? Really? I thought it was $4 for a coffee. Not here. So thank you so much. If we get a round of applause to Microsoft and the team here who helped us. And with that, I'd like to bring up our keynote speaker, who's far more interesting than I ever will be. So Katrina Reel, who's been in the Python ecosystem for a while. I'll let her see if she wants to admit how long. And while she gets set up, so Katrina is the global senior data manager of all things data at HomeAway, which is a little company that sells vacation rentals down in Austin, Texas. So she's got quite a bit of data on everyone's house and where they stay and how they like to stay there, and she's going to tell us a little bit about putting that in production. I've known Katrina for quite a while, and I know she's can be intimidating because when she first started working for me for a defense project, I brought her in, I let her meet everybody, and then I took off to go talk to a conference, and then they told me, oh, by the way, we need you to speak in front of, I think, 20 generals. I was like, oh, well, I have my new data scientist who can do that, and as I was off, I gave her the floor, and I was told that she blew them all away. So let's give a big hand for Katrina.
Thank you so much for that introduction, Andy. By the way, and also thanks for leaving me high and dry on that presentation. That was awesome. So I will admit how long I've been in the Python community. Actually, I started using Python in the fall of 1998. So long-time Python person, and I was definitely one of those people who debated long and hard about the difference between using numeric and num array. And so when NumPy was released, it was actually a really, really big event for me because I was able to, I was studying artificial intelligence at the time, and I was able to get my implementation of k-nearest neighbor into under a second for the first time in my entire career. And it was very, very exciting for me. But it's a great honor to be here. I feel like I've run the gamut in the data science world. So everything from oil and gas exploration to working in the finance industry, and also, Andy mentioning that we were working on human trafficking cases, trying to hunt down human traffickers on the internet, as well as fighting fraud or bad actors and doing security over the years. So it's really great to be here, and hopefully now we're going to talk about vacation rentals. All right. So just to give you a little bit of background on HomeAway, HomeAway.com is actually it's a website where we match travelers and owners with vacation rentals. So you may have heard of a company that rhymes with Air Shmee and Shmee, and we get compared to them quite a bit. But we are actually a different company. We were around longer, and we focus mostly on vacation rentals. And the big thing here is that we focus on the whole home. So this really is marketing to a vacation market. As mentioned here, have over 1.4 million online vacation rental listings. That's across 190 countries in 22 different languages. We have offices all over the world. We are owned by Expedia, which is located, headquartered in Bellevue, so definitely have the connection up here to the Seattle area. And I was talk a little bit about the data science team, actually, because it was really interesting what happened when Expedia bought HomeAway.com, I guess almost 2 years ago now. The entire business model changed. Before, HomeAway was really a matchmaking service where owners and travelers met, and they worked out their payments together, and they kind of took all of the whole transaction happened between the owners and the travelers. There was no marketplace involved. We only matched them up and basically directed traffic to sites. With the move over to Expedia, now we are a travel company. We're trying to integrate into the Expedia ecosystem. You may have noticed that vacation rentals are now being offered on the Expedia.com website. Those are from HomeAway. And now we are in a place where we have a marketplace, where suddenly the whole dynamic has changed. And this has caused us to need to use data scientists in order to study this marketplace, collect data about this marketplace, and better optimize this marketplace to make a better experience for travelers. So I actually joined the data scientists team about 15 months ago. I was the 4th data scientist that was hired over at HomeAway. We now have well over 20 data scientists, and the last year it's been very interesting to watch this team grow. It's also been very interesting to watch the company grow as machine learning has begun to touch all different parts of our business, which I'll talk about quite a bit. And so, as I was saying, data scientists have actually, we've infiltrated the company now. We're everywhere. And I'm very proud to say that, we've turned a company that had, over a decade history of being really just where they really just displayed data on their website. All of their data was set up for display, for fast display, and not really set up for mining, right? You'd be amazed at the amount of data that we were throwing away and not collecting. We've had to change the entire back end of the company in order to accommodate the data science team. So retrofitting data science has been an interesting experience as well, because nothing was built with machine learning in mind from the beginning. So, as I was talking about before, what we do, we have suppliers who provide inventory. We have travelers who want to book that inventory. And then we're trying to make that inventory findable and bookable. And so we have this marketplace between travelers and sellers. So what you may notice here is that I'm sorry, I'm going to move on. So what the data scientists do here at HomeAway, we are sort of the intersection of software engineering, statistics, mathematics, and data communication as well. So we're part data analyst, we're part data engineer, we're part, jack of all trades, and also just providing a lot of support and business intelligence to the company. I love this quote where it talks about data science basically being better engineers than statisticians and better statisticians than engineers. And I think that's actually a pretty accurate statement. So we are the team that develops the algorithms, predictive models, and software that leverage data from multiple sources in order to solve business problems. And the focus really is on solving business problems. Just out of curiosity in this theater, like how many data scientists do we have here? Awesome. I love it. How about data engineers? Excellent. How about application engineers? Awesome. Really cool. Glad to see you all here. And so Given the number of data scientists in the audience, this may be controversial, but I did want to at least lay the groundwork of what I talk about when I talk about data science. So the data science team at HomeAway is definitely very technical. We try to be language agnostic, so we do use R, Scala. Python seems to be the most popular though. My team in particular uses quite a bit of Python. So we kind of run the gamut across there. But we do, on the data engineering side, we've been using quite a bit of Hadoop and Spark in order to do ETL and kind of get our data pipelines set up. So that's been, so we definitely have a polyglot environment that we're working in, which has presented some problems that I'll talk about a little bit more in my presentation. But the machine learning and modeling is really the focus of the data science team. I try to keep the data science team really focused on solving business problems by creating machine learning models. And so that includes all of our feature creation, extraction, feature engineering, a lot of work with tuning machine learning algorithms, and then optimizing for speed and accuracy. And then we also since we do have to interact with our business shareholders so much, the data scientists have to be good communicators, be able to tell the story of what the data is telling us, and really make this come to life, right? Just a shout out to all of the amazing tools that we use typically in our pipeline. You probably notice, definitely recognize most of these. I am one of those people who uses pandas and loves it, by the way. But scikit-learn is a big part of our workflow as well. We'll tend to prototype quite a bit in Python and R, and then kind of when we move into the production systems, that's where things get a little bit more interesting. We'll talk about that. As I mentioned before, we do have a machine learning focus. So we're really trying to focus on just the supervised and unsupervised learning. And one thing I really wanted to point out was that the unsupervised learning is really in support of the supervised learning, because ultimately classification is the most important thing in what we're trying to do, whether it's a regression problem or we're actually trying to, we're trying to classify whether or not somebody's going to book. We're trying to classify whether or not this is a positive experience for somebody. We're trying to rate, what is the desirability of a property, or what is the desirability of a photograph, or is this a bad actor on our platform? These are the kinds of things that we're trying to classify for. But we may do a lot of exploratory analysis in the unsupervised world in order to support that work. So especially on the unsupervised side, I have to, definitely a huge shout out for topic modeling and things like that, where we have a lot of unstructured text on our site that we need to make sense of. And so being able to take large quantities of text, structure it in some sort of way, make some sense of what's actually in it, that's a big part of what we do as well. So some of our data science projects, obviously the most important one, ranking and relevance. This is kind of the core of the product at HomeAway. We were trying to match our suppliers and travelers, right? Inventory optimization. So can we predict what kind of inventory we have available in certain areas? So if we can predict what our supply and demand is in particular areas, can we optimize the price? So that's actually a nice tool for our suppliers on the site, because we can help with pricing. We can help with the revenue management and yield optimization. Geolocation services, so a lot of vacations are booked based on location. You want to find something near Disney World, you want to find something that's near New York. So quite a bit of work over with geolocation. I definitely have to give a shout out to GeoPandas and also Bokeh and Data Shader on that one, because we use that quite a bit in order to show what sort of areas are being booked. And it's a very nice visual tool. Identification of unfair market practices. This is actually originally what I was brought in to work on at HomeAway. So we have quite a bit of unstructured text on our site, as I mentioned before, so doing quite a bit of natural language processing in order to classify whether or not somebody is trying to circumvent fees, do something that might be some nefarious activity, if they are possibly, have a fraudulent listing or something like that. These are the kinds of things that we're looking out for in order to keep it, create a safe marketplace for people. Revenue management, as I mentioned before, is a big part of, supply and demand classification, and then also marketing ad spend. Obviously, trying to optimize how much money we want to spend in different marketing sectors, what are our most important areas to go after. And then another important one to mention in that realm is also bot detection. We have, quite a few bots that are out there scraping the site, looking for different listings, different information, things like that. And having been somebody on the other end writing bots to scrape sites, it's been a lot of fun to recognize the tricks that everybody's using. Because especially when we were working on the human trafficking project, we did quite a bit of scraping and structuring of unstructured data. So, but we don't want to waste money on bots, right? We don't want to waste the compute on trying to track their movements. We don't want to waste the time trying to figure out whether or not they're going to convert. We don't want to waste the money trying to target them with ads. It's very important for us to just, save that money for actual travelers and keep our site nice and responsive. So shopping cycle segmentation is a big one. We have an interesting problem at HomeAway that our data is extraordinarily sparse. I don't know about you guys, but I really only get to take one major vacation a year, maybe, if I'm lucky. Two, if, I win the lottery or something like that. But so people are not on our site all the time. They're not constantly interacting with it. They're not going to book a vacation every other week. So our data is extraordinarily sparse. And then there's also quite a bit of decision-making taking place, right? So the shopping cycle usually takes around 2 weeks, where somebody is coming back to the site, they're checking their different properties again, they're looking in for availability, they make an inquiry, they get a response, decide maybe not that one, they come back again, they email it over to grandma to see if she wants to stay there too, and then they kind of go through this whole shopping cycle that can be difficult to track, right? So fusing that data and being able to understand what's happening there is a big challenge. One of the projects I'm particularly interested in is the content generation from images or text. So this is where we start getting into deep learning, and we're using quite a bit of deep learning in order to try to actually come up with pleasing content for our site based on what we're seeing. So we want to be able to detect if images are pleasing to the eye and be able to detect what objects are in there, and then in some way present that to travelers in a way that would make them more interesting. And then I mentioned image quality kind of falls into that same category. But the main one I'm going to talk about is ranking and relevance, because it is kind of the main point of what we do. So we do have an interesting problem here that, when you come to the HomeAway website, we're going to ask, where do you want to go? What do you want, right? Why are you here? And so you type in a location. You may know about what dates it is that you're looking for, and then the next thing we're going to do is we're going to try and find, the perfect vacation rental for whatever it is that you're looking for. But the difference is here is that since we're peer-to-peer, both sides have to say yes, right? So while we don't have a simple ranking and relevance information retrieval problem. We have sparse data, we have, patchy data, we have a lot of and then we also have the case where when things are booked, they're then unavailable. It's not like we have an inventory of multiple rooms or multiple vacation rentals that follow that same description, right? So when somebody's coming to the site and they book something, it's then removed from this process, right? And so, which can also, given the amount of time that it takes to book, and you may end up in an inquiry flow and things like that, it could be challenging, right? As I mentioned before, our flow is very different. So when people come to our site, they have a tendency, they're going to want to ask questions. They want to know, are pets allowed? Can I bring, how big can my dog be? Do you have pots and pans in your rental? How close is it to the beach? Things like that. So they're going to ask a lot of questions. It makes them feel more comfortable, especially when you're going to book a vacation. You want to make sure everything's kind of perfect. So we have multiple flows people can go through. And so we do still have a subscription model where people are able to subscribe and just post their information up on our website and then take payments offline. But we also have a pay-per-booking flow, which is what we really focus on, and kind of the future where we're going is to take everything into the marketplace. So So this should be pretty familiar to most people. In the ranking and relevance idea, what we're trying to do is we use learning to rank algorithms. So we take their components of how closely does this property match what it is that I'm looking for? How likely is a traveler to book this property? How much revenue are we going to make from this? And then also, how likely is the supplier to accept this interaction? Because both sides are going to have to say yes. So we have to optimize for all of these things. And this can also be location dependent. We also want to get into the place where we are able to identify whether or not somebody is a good actor on our website and reward those who are being good actors, boost them in the rankings, and then and kind of push down the ones that are more likely to give people a bad experience while they're out at the property. So what we do here, this is, like I said, it's pretty straightforward. We have all of our training data. We have an idea of what the ranking should be. We are looking to mimic this ordering, right? So we take lots of different data, click-through rates, all sorts of conversion information, things like that, and then we try to basically run it. We're going to run it through a regressor. So in this case, we do use gradient boosted trees regressor in order to come up with a numeric value to determine the ordering, and then we sort according to that numeric value. In order to make this fast enough to put into production, we do it in 2 passes, which is also very common in information retrieval. So we do a lot of static feature generation on the front end in order to narrow down how many candidates are in our search, and then we'll run the machine learning model on that as fast as we can in order to bring this all up onto the website. And that's where we actually will rank according to that regression score that comes out of our gradient boosted trees algorithm. So, and as I mentioned before, all of this has to happen in a production system. It has to be behind a click. So when you come to the website and you enter in all of your information, I don't think people like to wait, right? It's like if we were to say, oh, hang out here for a few minutes, we'll get back to you with all of the great, vacation places that you're going to get to go to. People want to look at it immediately, and they want to be able to react quickly and change their dates and look and see what different availability is available, and things like that. So as I have said many, many times before, so now what? I've got this amazing model. It gives me, the perfect ordering of everything, where everything is, 90% likely to be booked on the very first position. And I've got, all of my metrics look fantastic. The accuracy is looking good. It runs, unfortunately, in 30 seconds, but, whatever, we'll work on that later. And what are we going to do? Well, you now have to actually put this into a system. So I always ask people, if your predictive model doesn't make it into production, who cares, right? It just doesn't matter. I have these, I can have the best model in the entire world. I use all of my tools in my fantastic ecosystem, all of my PyData tools. I've shown amazing visualizations and everything like that. But now, if I can't bring this to life and get people to use it, who cares? And so that's what I'm going to really focus on. And that's what, especially as a manager over at HomeAway, I spend a lot of time trying to develop the patterns to help us put things into production quickly and for all of those different applications I was talking about. But focusing mostly on our learning to rank problem is kind of the most interesting or the most obvious one people are used to dealing with. So in order to talk about production systems, we kind of have to talk about the 2 different environments that people work in, right? So we have our experimentation or our training area, right? Where we want to optimize for flexibility. We want to have access to all of our data sources. We're going to be exploring quite a bit. We need to be able to do fast computation and quick exploratory analysis. We want to look at our data as fast as possible to tell whether or not we have enough signal. We want to know whether or not we have enough signal to support the hypothesis that we're trying to prove with our machine learning model. So quite a bit of work with feature engineering and model training. So this is kind of where we come up with our ideal version of the model, right? So we have all of our different pieces put together. We have the like I said, it's the ideal version of what it is that we're looking for. It's going to give us our highest accuracy, and we want to get that as good as possible before we move over into the second environment, which is our production or scoring system, right? Now that we've done all of this really great work, now we want to put it behind a click. So this is where we have to worry about fault tolerance and security. We need to make sure that it's fast and that we have monitoring on it. Especially when we talk about certain architectures, which I'll get to in a minute, making sure that other services are not hitting our services is a big problem, right? So that can be from both a security standpoint, but also from a performance standpoint, making sure that our services are set up in such a way that we're able to tell whether or not we're losing performance because another entity might be hitting it, right? We want to be able to support both batch and real time depending on what the application is, especially for some of the identification of bad actors or people who might be doing nefarious things on our website. That's really a job that can run once a day. We can kind of take our time with that. We can identify those bad actors overnight or something like that. But real time, those would be more the like the best match algorithm, right? Where we are actually trying to click and then search for all of the properties that match what it is that you're looking for. And then also just ease deployment, right? Deployment is a big issue. I'm going to talk about that one probably to death. But deployment is really kind of one of the biggest issues in how we deal with how are we going to version this? How do we handle governance and provenance? How do we actually, reproducibility can be a big issue, right? So even in the case where we may save our training data set, we have all of the code for generating our model. Depending on the type of model, there could be jitter in the model, right? So you actually can end up with different versions of the model even with all of the same ingredients on the front end, right? And that happens all the time depending on what kind of model it is that you're looking at. So it could randomly seed differently, and then you end up with a slightly different model with different parameters in it. And so how do we actually handle that, right? How do we persist that? How do we get those out into the environment? So since I mentioned I started back in 1998, I'm going to talk about, I've done quite a bit of work actually in artificial intelligence since the very beginning. And we really started by writing all of our models in C++ or Java in order to just keep everything all in the same place, right? We wanted to, the tools not in the Python ecosystem were not as mature as they are now. So you really kind of had to be in a place where you could write really solid C++ and Java and just implement these algorithms over and over and over and over again, right? So I always joke with people that I think that I can probably implement PCA in my sleep. I have pretty much implemented it in every language you can imagine. and that it really created a problem, right? Where you may have, I was talking about this dichotomy between having a really good statistician, mathematician, and modeler, but then also having a really good engineer. And finding those two things in one person is very difficult to find. The handoff between a data scientist and the engineer can be very painful, right? Like I mentioned, if we could get data scientists, or I guess they weren't really called data scientists back then, but if we had modelers who could write in C++ or Java, then all of the validation, verification, feature generation, model execution, everything was always in the same language. But we also may have a situation where I love to fast prototype in Python, and then I would try to translate it over into C++ or Python. So in that case, I have double the overhead, right? I have to then implement it on the Python side, then over on the C++ side, and then I got to make sure they match, right? And which could create some problems. As I mentioned, versioning issues come up all the time. One model does not equal one model, right? We can't, reproducibility is a big problem. And then where is the line between the software development team and the data science team? this creates, the engagement model is an interesting idea just in and of itself. Where does one end and where does the other one begin? And that really depends on the people on the team and the understanding between them. So some of the advantages is, right, better performance, integration with the application. The application is in mind as you are writing the implementation. So, but that means that it doesn't tend to generalize well. It can't be reused as well as you might like. I wouldn't be able to transport it into another application without possibly rewriting the entire thing, depending on how well the interface was set up. And then drawbacks being, error prone, and this is a slow process, right? So one of the solutions over at HomeAway that we actually use, and this is also at previous companies I've worked at, we've also used this, is using PMML as an intermediary. So this allows us, this is an XML-like prediction model interchange file format, right? So this gives us a descriptive way to describe what it is that we created. So no longer are we in the position where we have to actually serialize a model. We don't have to, worry so much about whether or not we can retrain according to a certain fault tolerance or something like that. We now have a description, and then we can version control these files, right? Some problems that kind of come up here, well, actually I'll talk about some of the advantages, right, is that this can be language agnostic. So this is Python and R, it really doesn't matter. Either one can be supported. Both can, create PMML. There are several JVM-based scoring services. Over at HomeAway, all of our web services are all JVM-based. So this is a big issue for us, is being able to deploy into these environments where it's not necessarily the native language of all of our data scientists. So using this as an intermediary has actually worked out relatively well. The problem is that PMML is not necessarily tracking to all of the different models that are available, right? And so, especially if you move into the deep learning world, things like that, or if you do a lot of really heavy natural language processing, there's not PMML representations for a lot of these model types. So as we move forward into that area, which I think is becoming very, very popular, we don't have a PMML representation to help us. The files can also get really big. This can be very interesting. They are human readable, but at the same time, some people balk at the, if you give them over a gig size file to, represent some random force that you transit or something like that. And then also the PMML execution engines may differ in implementation. So you may find that different execution engines, when they reinstantiate the model over on the PMML engine side, don't necessarily match what it is that you were expecting and whatever you tested with, right? There is an open source open scoring engine that's available that I use quite a bit for testing, but definitely it still creates a lot of challenges. We also do have the situation where we still have to rewrite all of our features again over in the JVM side, right? So I haven't actually lost that piece where I have to re-implement over on the Java side, which, I now am in a position where I have to validate all my features once again on the other side, make sure that I have parity across, my experimentation environment and then my production environment. So what we're moving to is actually a microservices architecture. So the nice thing about this is that we're enabling the data scientists to develop experimental models and production models in the same language. So we've definitely, I think, gotten over the hump where people say, oh, you can't put Python into production. Like, yes, you can. Just have to be careful about it, right? And so if we can reduce that step, where now we have a data scientist who can create a model, they can use all of their tool stack, so everything from visualization, exploratory analysis, use their Jupyter notebook in order to do all of their experimentation, train everything up, get all of their data set up exactly the way they want. And then we can containerize that particular model. And now it's available to us. We can version that container. We can scale it. We can use it any way that we want. So once and as many images of that container that we spin up, we can just put a load balancer in front of it, and suddenly we have a scalable microservice architecture. This is, like I said, this is kind of where we're heading towards. The big things to bring up here, obviously, are things like adding network latency. So, but even in our time trials, even between PMML and using Python microservices on just with a REST API. So even working with something as simple as just like a Flask REST interface or something like that, across our network, we're still finding that the scoring is faster on the Python side than using the PMML scoring engine, because it also allows us to batch. If you mentioned the, I was talking about how we are scoring a whole group of properties all at the same time. That's really, we're able to batch that up and come up with scores all at the same time. So as a result, we don't have to sequentially score every single one and collect all the scores, which is what we're kind of stuck with over on the open scoring side. This is kind of where we're moving. And so this, supports the different model types that we're looking for. We're able to use Spark, use deep learning, able to use NLP-related models. But it does add another dimension to our team, where suddenly DevOps support is very important, right? I definitely a shout out to the DevOps people, by the way. They definitely make everything possible. And then there are several different ways to approach this. So several that we've been looking at, like I said, is just putting a REST interface in front of everything. So we're just making REST calls across the network. But another thing that we've been playing around with is quite a bit is using protocol buffers. So using protocol buffers with RPC, so remote procedure calls, has been working out pretty well there as well, which saves you the JSONification of the message across. You just use the data directly, so you're able to kind of save the memory of reformatting your data as it comes across for the remote procedure call. So those are just a couple of ideas to kind of throw out there, and where we're going over in the home away area. And with that, I'll just go ahead and stop there and open it up for questions.
Okay, so everyone hear me okay? Oh, there we go. I'm going to hook up a lapel mic while I do that. As I said earlier, if you want to tweet questions at PyData Seattle, I will check on my phone, hopefully, assuming you don't all take down the Wi-Fi, and I'll ask Katrina questions. So I'll give you all a minute or two to come up with some questions. Thank you.
That's okay. Maybe I should leave it though.
All right, can everyone hear me? You good? Okay. Now, through the magic of Twitter, let's see what kind of questions we have. Actually, I'll start with a question where I look for something. Coming from I'm more the engineering side than the statistician side of data science. Have you found it beneficial? What are the benefits and the drawbacks you found from having data scientists, I've heard the term be technologically promiscuous, between using things like Python and R, and basically any tool they feel like, and then having to productionize it all in the end? Have you found where are the benefits in terms of allowing people to use any tool they want versus trying to standardize across your team of 20 data scientists, try to help each other out, and so on and so forth?
Yeah, it's a really great question, actually. And this is something that I've actually been on both sides of this, right? So both as an engineer implementing, as well as on the data science side modeling. I personally believe that hiring, data scientists who have strong programming skills is a must. So especially on my team, I tend to screen for that pretty heavily. So they've got to be pretty fluent in Python and be able to work in that kind of environment. I found that because they are the ones who really truly understand what it is they were trying to express, right? When you have a model handoff process, I find that the engineers are not going to be nearly as invested, right? So there's a lot of misunderstanding about what features mean. There's a lot of bugs that are introduced because people are misunderstanding what is happening. And so I think, which is not any knock on the engineers, but they were not part of the creation of this. They did not, they don't understand like what is the pure meaning of this feature and why is it important. And then making sure that they understand, why that may be the most predictive feature in that model, right? And how important it is that, no, it's not okay that you have a tenth of an error, like rounding errors matter, right? And so being able to understand like how important precision can be, I really think the data scientists need to be positioned in a place to do that for themselves. And so I believe in enabling data scientists to do things themselves as opposed to, but at the same time, we have extraordinarily talented data engineering teams and application engineers over at HomeAway who do handle this trade-off.
So lesson learned, floating point, dangerous thing to use. So we got one question here about how much effort in data science at HomeAway is focused on data cleaning specifically, and what techniques do you use to do that data cleaning?
Oh, that's always the fun question, right? I'll just say an enormous amount of time cleaning data. As I mentioned before, at HomeAway, most of our data was set up for display, not necessarily for mining. And so being able to restructure the data in a way that was more data science friendly is an ongoing process, actually. So we work very closely with our data engineering team who are creating the abstractions on top of our data. So we actually, our raw data coming in is usually not very useful to us. Things like even looking at clickstream data, which may still have bots in it, which we were talking about before, we may find that there are some anomalies in the data that don't necessarily matter or that may skew the process of modeling. Our data engineering team has actually created several different modules or abstractions on top of the raw data, and that is what we are to use. So it's been enriched, if you want to think of it that way. And I really like this model quite a bit because the other nice thing that we get out of that is that then the data is the same across both our experimentation and our production systems. So by creating an API that allows us to access data, we can just switch out the back end in a way that allows production to just kind of seamlessly pull that data in, and we can know that we have this, that they mean the same thing, because that's another problem that we run into is with data coming in on a modeling experimentation case. We may find that the model is receiving completely wildly different data that's been filtered or has some sort of rule placed on it or something like that when it actually gets into a production system. And then our model is nowhere within the boundaries of where we thought it would be performing. So so a huge effort, actually.
I can only imagine. Yeah. So another question we had was in reference to your use of protocol buffers and whether or not you're using HTTP to do the transport or not, or some other alternative, such as are you using gRPC to handle all this in the back end, if you happen to know? Yeah,
so that's kind of the the Google pattern, right? So the gRPC, absolutely, that's what we're using.
For those of you that don't know, gRPC uses HTTP2 behind it all.
Yes.
Another question was...
Which, by the way, creates its own problems in and of itself, right? So transferring everything over into HTTP2 has also been an engineering task to complete, just to throw that out there as a warning.
Yeah, speaking from experience, if your systems are prepared to handle HTTP2 traffic, you kind of have to test that first to make sure someone doesn't fall over if your servers all expect only HTTP 1.1. Right. Another question we had was, could you sketch out your deployment strategy for a model in terms of reversioning on a RESTful API? So on the RESTful API, well, this is what's nice is that we've been trying so many different things. We have a lot of different patterns, right? So I'll talk about what we did and then where we want to go, right? So the first version of the model that we created was actually so I don't think it's any big secret or whatever that we monitor the communications on our platform. So when people send an inquiry flow over to our owners, we're monitoring that. So I actually developed a machine learning model that looks for
people who may be, trying to pull transactions off-site, which is against our terms of service, right? That's how I get paid, so it's kind of important. So we do have a model that's looking at the language to see, are they possibly trying to circumvent our redaction policies and our different terms of use policies in order to move a transaction off-site and then maybe, create, a PayPal link or something like that. And so while we're looking at this particular one, we were able to deploy just natively. So I created I'm a big fan of Anaconda. I don't know about others, but and also Conda. So I created a Conda package for that particular application. Probably not the world's best example of using Flask in production. I know you're not supposed to do that, but it scaled pretty well, so I left it in there. And so I just put a REST API in front of it and created a Conda package. We spun up multiple copies of it over on the application side. So for our secure communications platform, these all run independently. So they created as many copies as they needed to support the traffic that's coming in, and it's just natively running. And then they put a load balancer in front of it, which will direct the traffic and port forwarding and all that stuff like that. But I do like the idea better of moving towards just a container, right? So I was mentioning using Docker containers as a way to create containers for all of these different models. I like this idea a whole lot better. We basically can create something internally like a Docker hub or something like that. And people can pull whatever version of the model that they need, deploy it as necessary. Because even with a Conda package, as easy as they are to use and as easy as they are to create, there still can be some misunderstanding about what's happening there. And so trying to even remove that piece of it, I think, is going to be a big win for us.
So we've gotten a couple questions actually about how you handle your models. Specifically, how do you, I just lost my place, of course. Doing this live, always fun. Basically questions along the lines of how do you create your models if you don't necessarily know the outcome? How do you handle retraining? How do you monitor them? Just generally, more or less, how do you handle your actual model strategy?
The actual operatization, right?
Love that word, don't you?
Yeah.
Was it O13N or something abbreviated? I can't remember.
Sure. So, I mean, when we're doing our model performance, right, we have to agree with our business partners about what the metrics for success are first. This goes back to those great communication skills that we're trying to foster on our data science team, right? Is being able to agree what are our metrics for success and what can we actually prove measurably, right? So obviously the most important ones that a lot of people want to look at are precision and recall, right? So using a ROC curve, is kind of the most standard way to figure out what our operation point and what we can expect from our how this is going to perform, using confusion matrices and things like that in order to figure out our, true positive, false positive rate, things like that, right? But what we've also found that in other applications, especially when we're working with money or with values, that we may want to optimize for other values as well. So if we have a really great recall or precision and we're, catching a whole lot of transactions that are $1 as opposed to one that may be $100, we may want to optimize for the amount as opposed to the actual instance that we're catching, right? So it can be very application specific how we determine what that success criteria looks like. And so we obviously, have to determine what is the threshold of what's allowable before we'll, once we know our experimentation is done, it's in a state that we would like to put it into production. So, that can depend from application to application again, right? So in some cases, any improvement that's better than a coin flip is probably good. In others, we have to be very precise. If we're going to accuse somebody of doing something against our terms of service, we want to make sure that that precision, that recall is super high. We want to have, less than 1% false positive rate. We want to be very, very clear that we're not accusing people of things that they're not doing. So we have to discuss that with our business partners of what the allowable threshold looks like. Once that's been met, we go through a round of A/B testing. So we have quite a huge A/B testing harness over at HomeAway in order to determine how well something is doing. And we'll test it until we actually reach, stat sig and are able to make a call on whether or not this is an actual improvement. And then when we do retraining, this comes back to the monitoring I was talking about. If we see a lot of drift in the data, because we can kind of monitor what values are coming in. So we can kind of, if we start to notice a lot of drift, if we start to notice that our signal is starting to get a little wonky, our anomaly detection algorithm is kind of going off the charts, things like that, probably time for a retrain, time to start actually looking at it. Because we do want to be in a position where our data scientists are moving from project to project. So we don't want them to be 100% on this project forever, right? Mm-hmm. So at that point, we would like to alert people, have them come back and do a retrain and redeployment.
Just to let everyone know in the room, it's 9:57. I'm going to try to squeeze in one more question with Katrina if she's amenable to it.
Sure.
But if you need to get to your next session, please go ahead. And if I could have Felix, our next speaker, come up and get ready for AV, that'd be fantastic. So one question someone had was on the technical side in terms of, are you guys using cloud for any of this? Are you using AWS or Azure? Are you using functions? You've already mentioned you were using Docker and containers. Basically, just how you're managing your infrastructure.
Yeah, so we're cloud-based. I'll just leave it at that. Yeah.
All right. And let's see if we can squeeze one last quickie. I think there was one question about how you handle the versioning of your models specifically, but I believe you covered that. So I'll leave it at that. And thank you, everyone. And thank you, Katrina, once again.
Thank you. My pleasure.
And the next talk will start in 2 minutes.